Hello.
Hello.
Yeah, good evening.
Good evening,
Good
Ravi.
evening. Good evening.
So, how are you?
I'm fine.
Fine.
I think Kaushik, you are coming after long, maybe 2, 3 weeks, no? You missed.
Yes. Just 2, 3, maybe 1 month.
Okay. 1 month you didn't. Yeah, January complete.
Yeah.
Complete January you didn't join that. Okay.
This is the effect of 2025.
Okay. So it is effect.
So now, now there is budget, so we are a bit relieved.
Uh-huh. Yeah, they increased our this, no? Mm, the
Middle class income got
yeah,
increased a bit.
yeah, little bit increase. So
But anybody above 12 lakh, they are not relieved. I mean, the same.
yeah.
No,
Yeah, some.
that's
But
okay.
some are okay.
No, that's okay. People should now tell that okay, you reduce my salary to till 12 lakhs. I will.
Many are interested in the floating roof tank. I think Ramakrishna, your topic is like many. I think.
You're lucky, Ravi.
Okay. Thanks. Okay, I think
No,
one.
actually, I am more interested because I don't know anything about that. That's why I'm more interested on.
Okay. Okay. Can any new guys? I think Manigandan, you are new. Can you please introduce to the group?
Yeah, hi, this is Mani.
Yeah.
I'm from Chennai.
Yeah. Can you please
Yes,
introduce?
actually, I'm in.
Yeah.
Actually, my field is the static equipments.
Okay. We are all. I
Past
think all are
18
static
plus.
only. Yeah.
Okay.
Yeah.
Past 18 plus years of experience.
Mm-hmm.
Now I am working in Dubai.
Okay. So total 18 years. You are in the static. Right?
Yes.
And the first time you are joining this meeting,
Yeah.
and you recently joined our group, or you are with long back?
Actually, long back, I think 6, 8 months before, I think had it. I think.
Okay, so today you joined due to the topic, or you got the
Actually,
time?
so no, I'm not yet seen the topic, but actually I want to join. Actually, many times I tried, but I couldn't able to join.
So today.
So today I have some bit time I have, so that's only I joined. So
Okay, welcome. I
many
think
times I tried.
yeah. So timing we modified because normally we used to conduct 8 o'clock, but 8 o'clock has some other program, so that's why we preponed it to 7 o'clock. Otherwise, we used to keep it say 8 o'clock. Okay, however, we welcome you. And any more?
Thank you.
I think Farhan, answer. You are also coming first time? Farhan?
Hi, this is Farhan. Yeah,
Yeah.
no, it's not the first time, but after a long time, I have been joined this discussion. And just to introduce myself, I'm from Saudi Arabia, the lead mechanical engineer.
Okay, Farhan. I think your first
So
time when
the
you joined
topic
on
is
that time.
quite.
Yeah. I think your first time when you joined on that that day only you just joined our meeting.
Yeah, yeah. Your memory is quite good.
Okay.
Thank you.
Welcome. So how is your work now?
And the time is also it's suitable for me because at the 5 o'clock or 5:30 here, I'm not able to join because of another activity here. So at this time, I
So
think
you want to
it's good.
keep regular as a 7 o'clock?
Yeah, that would.
Because
But it's
previously we.
depend on the another participant also.
Yeah. Previously we used to go to 7 o'clock. Means 7 o'clock only at our time here. So, but again, somebody has told that 8 o'clock will be better. We'll be a bit relaxed. So we'll shift it to 8 o'clock. However, we'll see. Again, we'll make the voting. If the comes, which one comes more, we'll keep same time. Okay. Can we start now? I think Haseen and Stalin are our few older guys with us. Okay, Stalin, you are also coming after a long time. Haseen, you are also.
Good evening, sir. Yeah, I have also come after a long time.
Yeah. Okay. Can we start now?
Yeah.
Yes.
Sir.
Okay. So today topic what we discuss thought that last time while discussion they raised that floating roof tank will be the topic we will conduct, and that is as they told that it will be not known to many, so we will carry this topic, and that's why we today we are prepared somewhat, and I told you what your time I will get, I will prepare it, not that depth. But whatever I can share my screen, so you will get. Are you all able to see my screen?
Yes, sir.
Yes.
Okay.
Yes, it's visible.
Okay. So as I am representing this Shri Asante company, which is located in Pune, and today's topic is this what we are told, the floating roof tank. So as I think now today is there are a number of experienced guys here who have more than 18 years or 20 years. So there might be some of them are already with this one, with floating roof tanks and that one. So that floating roof tank normally what we see, it comes in like this. So this is the floating roof where the tank, which normally API-650 what we do, in that one the shell design will be normally will do as per that one, and the roof what is there. So this part is the roof. So which that is roof is floated on that liquid. So whenever liquid is taken out on that time, the roof is come down, and whenever liquid again filled in, the roof is moves up accordingly, the filling of that one. So this is normally when we use where when there is some losses of gases and that one. So to avoid that one to form gases in between the roof and the tank, so we will directly keep this float on that tank on the liquid. So to keeping that one, the formation of gases will be avoided. So it will be there is no gap, so there is no space. So it will be floated on the liquid. So gases formation will be almost avoided. So to design that one again, we use API-650 only, but the concept and that one will be different rather than that what we use for this cone roof and other type of roof, the design of that one. But in here also we have the two different types of floating roof tanks. One is that internal floating, which is the comes inside of that one. Means there is complete this cone roof, whatever we say that one. The top is completely closed one, and inside that there is one more float is there. So that float will be floating on that liquid. So whatever the gases or whatever, it will be controlled by this floating roof, and still there is a gap is there. So this completely, if nothing to fall on top on that one, so this again roof is closed with like our cone roof and tank on like that. And one more type is that external floating, where there's a roof is not there, but only the deck which is floating on the liquid, that is the second one which we are saying. I think my mouse you can visible, no? So this is one what and the external floating roof tank. So these both will be used to avoid the formation of gases. But this is the first one with lesser means lesser places it will be used, where again the cone has to make, again the float has to make. It's a double, the roof cost will be doubles here. But this is normally used in this gasoline or crude oil and that type of this one, where your gases will be formation, it means avoided much here. So here will be again completely closed, but top is open. So, but one roof cost will be saved here, you can say. But this is again some hazardous and that one type where the chemical storage or refined product storage, where we'll use this external floating roof type. And the whatever the parts with it comes to this one is, you can say these are the normally the parts which comes in this floating roof tank. So normally one is that what we say this deck. So this deck is called a roof. So this roof is whenever it comes down, so there is a leg. So to hold this deck on bottom when it comes, so this deck is required. Deck leg is required, and to seal this one, because this is deck when moves up and down. So this when to gap between this end of this float and this shell, to close that one there is a seal system. So that is sealing system. And whenever there is some liquid will be, when rain something comes, so to that whatever liquid comes on this one or rain water, to drain that one, again the drain system is provided in this float. And to go on up on this deck, so we have some rolling ladders. So that rolling ladder will be connected here to the top of this one. Whenever it goes down, so this rolling ladder comes down along with this one, and whenever it comes up, then again rolling ladder comes up along with this one. And there are some nozzles like vent, hatch gauge, and what you're required as per the requirement of client. So these are the main components of this one. So normally this is the whatever the design and what you will do. The complete shell and that one design will do with this normal cone roof type, or what you will do. The shell design 1 foot method or variable foot method, that will do. But the deck design, again, this deck design will be normally the appendix are given for this deck design. So this deck design, what actually that takes, no, that will be there are 2-3 different types where we'll see. So this is, if you can see, so this is one. This is called single deck. Means here you have this deck. So this is the single deck. Means one plate is there, where your end is there. It's a floating, means float, where you can pontoon used to say for this one. So here inside this is complete air is there. So this, due to this air inside, means it's a completely closed one. So this is holds that complete top of that plate, so to float on that liquid. So whenever this your liquid filling, so this due to this float or pontoon, this deck plate, it goes up, and whenever it comes down, this again this deck comes down. So as you can see, this whatever the liquid or that one, so this is the draining system of that one. So it goes in this draining one. So, and whenever deck comes down, to hold that deck, and this is the legs of that one. So which due to that one, it stops to it not to hit that bottom of that one. So it's stop this deck on that one. And similar way, we have some manholes on this one, and some pontoon manholes also there. And there are some here there is some gap between these two. So due to this gap, no, there might be some gases may form. So to take care of that one, we have this rim vents and that one. So wherever the gases when forms here, so that can be vented from this rim vent and that one. And this pontoon manholes and roof support and bleeder vents. So again, the bleeder vents and that one, they similar to our vents and that one. So whatever the gases and that one comes, so that can be vented through here. And some gauge hatches and that one. So these are the single deck. When there is a single deck, so only one plate is there and there is a pontoon is there. This pontoon design we have to do as a like considering buoyancy calculation and that one. So that is given in as per API appendix and that one. So we have to do considering that one. This pontoon, this is circular one. So considering that one, how many pontoons means this is in a parts. It is not come. Its section is divided into parts, like in our tank and this water tank and that one, how they divides the different sections in that one. Like that, this pontoon is divided in between. So that pontoon, whatever comes, so if one pontoon punctures or two pontoon punctures, the how it will be means here, if you on left side, if you one pontoon punctures, so maybe the how it tilting will be take care, or how much it comes down. So even that normally we calculate this pontoon puncture as a two pontoon punctures and that one. So two pontoon punctures also, whether it will take care or not, like that we will calculate in as per API the sections and that one. And this is one is as a double deck, means where as only the end is pontoon is there, but here complete deck is two. One is at bottom, which is floating on that liquid, and second one is at the top. So whatever the top is there, so complete will be filled with air inside is there. So you have the gases, so it holds that one to float that one, like our ship and that how it's completely filled with top portion is filled with air and that one, no? Like that it is there. So here when this double deck comes, no, whenever your size of this tank is more, and that small pontoon cannot take that much to hold that complete the weight of that deck of that one. So on that time we'll go for this double deck uh, double deck type floating roof tank. So here also the same way, where we have the where manholes are there, some end there is a rim, seals are there, and there is a rim vents are there if gases forms, and that one again the manholes are there, and draining systems are there, so how it to be drains and that one. And again the leg supports are there whenever it comes down to roof to hold that one. So similar way, but it is in bigger size will be there. So these are the mainly it the working of this double deck and single deck. Okay, so if you have anything you can, I think this much. Any other anybody?
Sir, this entire roof design will be governed by API-650, right?
Yeah, entire design will be governed by entire design means now this whatever deck
The
is there.
roof, only the roof.
Yeah, roof.
Yeah.
No, Ravi, my question was that, yeah, one is that the weight of this roof that should be held by that pontoon volume, that whatever that the. So
Yeah,
that is one I understood.
yeah.
But how they will decide this thickness of this deck, how much it should be? For that, is there any calculation, something like that?
Yeah, there is a calculation. API, if you refer the appendix in that one, there is some calculation given the floating roof tank. Yeah, as I told you, that they will verify with that whatever the roof weight is there. So that roof weight, how much should be the size of this one? The left side, how much height will be? Right side, how much height it will be? This pontoon height and that one, how much size will be that one? So all that information is available in there. So accordingly, we have to calculate, and also they will verify that if one part means this complete it is circular way. So one part if it fails, so how it will be the other part will take care. So like that one punches the others punch, how it will take care. This also is given in there.
Okay. I mean, this how they will do the, okay, that I understood. How they will calculate this deck thickness? I mean, what are the loads considered? Any?
As a roof load only, whatever we do the designing, no, our roof load considering the in cone roof and that one. No? Similar way in I think somebody's message that appendix C and H, it's already there in for this floating roof. So if you refer there, there also says that this is the weight and that one to be considered to calculate. So how whatever the total weight comes. So we have to take that weight and apply on this one, the buoyancy, like our ship and that one. How much the gap or how much the space we have to keep that buoyancy. Then only the it can.
Buoyancy, I understood. So I'm particularly understood thinking about, for the deck it's like a flat plate.
Yeah.
Where suppose if rain comes, so certain up to certain height, the liquid weight will be coming on that. So that how the calculation and all.
Yeah, that weight total deck weight plus the rain weight plus whatever the snow weight or whatever sand weight, whatever comes, no, that total weight will be considered while designing these pontoons. So how much this size will be kept so that the complete even these loads, deck load, the sand load or rain load, water loads, the total loads to be taken care of this one. Then only it can withstand with that one. So whatever rain comes, maybe you can say 1 hour or 2 hours, whatever our 24 hours rainfall. So that rainfall weight also to be considered. And also there is some design where your rain, whatever rain comes, it will be drained through this drain nozzle.
It's like a floating section arm, that one.
Yeah, floating section. This is moves along with these decks up and down. So it is connected to deck end point.
Okay. Don't have any more questions.
Okay. Anybody? Any others? I think I finished quickly.
Ravi,
Yeah.
could you please tell, is there any impact or any criteria for going for floating heat? I mean, floating roof API tank. I mean, is there any impact, especially L by D ratio?
This is not depending on L by D ratio. This floating roof normally we go for whenever there is a formation of gases are more and losses due to that one will be more, like in petrol and that one. the gases formation is very quickly. So if you keep something on that liquid, so the formation will not be there. If you don't provide any gap between the liquid and the solid metal, so the gas formation will not be there. So like that, if the liquids are different liquids are there, so in that liquids, normally we will go for this floating roof. They whenever they don't want, like as I told, gasoline, crude oils, these are where your formation of gases will be very quickly. So to avoid that one, they normally prefer to go for this floating roof, and they will directly keep that one on that liquid. So the formation of gases will be not there. So if formation is not there, then losses also not there. Because if you keep the gap between this deck and the liquid, the temperature in between them are get increased. So temperature if increases, then the formation of gases will also increases. So that if gases formation increases, then they have to just vent it out because they cannot keep inside that one. So when they vent it out, there's complete loss for them, that liquid, or their whatever the cost they have to bear for that one. To avoid that one, normally the which is costly liquids or
That
oils or gases, they will.
that's clear, right?
Yeah.
Yeah, that's clear. I'm just concerned about the selection of floating roof, the type, double roof, and pontoon roof or this double deck.
Yeah.
So in case of large diameter,
Mhm.
we require the kind of rolling ladder, correct?
Yeah, rolling
To
ladder is required.
down to the top of the roof.
Yeah.
So that also, I think, the L by D ratio is to be considered. How the ladder provision is provided.
Ladder actually ladder will be provided where yours the depending on the how much it comes down or up in that one. So this is again, as you told, the ladders, I think almost all the tanks is required on that one whenever it floats on that one. And L by D ratio, it's not the ladders. I think I have some other things also to show you. The ladder.
No, commonly, what I heard, it should be less than 1. The ratio should be less than 1. So rolling ladder is provided.
Rolling ladder, again, as I told you, this is because this is rolling ladder, as I'm just showing you. So this is
Correct,
rolling ladder
correct.
where when your deck comes up, it along with that one it comes up, and whenever it goes down, along with that one goes down. But it again, it's not depends on the your diameter or that one, because it's almost every this you can see here, everywhere you can require, even it's a pontoon type, your this one is required, this rolling net, because how many nozzles are there, how many vents are there, how many you want to maintain this maintenance and that one. So on that time, this rolling ladder is required. So rolling ladder, just the it is required whenever your nozzles are maintenance are to go there, whenever it's down and you want to make some maintenance in there, then it's required. Otherwise, so how we'll do the maintenance in that one, because almost all the this floating roof is require this rolling net, because we didn't come across like that. And 1 by d by ratio on that one for the rolling ladders. For the this one, the requirement of pontoon and that one, normally we go for double deck one, above maybe around 15-meter diameter. Above that one will go for double deck, and single deck below 15 meter we'll keep for this pontoon type single one. And you're clear, no?
One doubt. Weight of this top roof impact the shell or bottom plate thickness?
Top and bottom plate thickness, due to this floating roof design, it as similar whatever we'll do in the other cone roof and that one. Similar way we are doing this one. The whatever the weights and total weights we have to consider. Similar weight is there. But in cone roof, normally the end part, whatever your end part, there your cone is comes and sits. So that is not there here, because this is completely considered as a one part. So because it's anywhere it's moving from top to bottom, this roof. So only the top portion, like your you have no need to provide the top part will be with stronger, like the particular place where you need not to be making it stronger like that here. So here is just it's just touching to the shell, and there is a primary seal, secondary seals. These are the there. So it's not directly touching to your any walls or that one, or any loads it transferring to these walls or any bottoms to that. And bottom only this whenever it comes down, it sits there on that bottom, and to avoid any damage in here, so they keep legs for that one to sit on the bottom, and accordingly they will drain the complete liquid from there.
Okay, sir. Thanks for explaining.
Okay. Any more?
And regarding the ladders, I couldn't understand how we can be able to land on the roof if it is down.
If it is down, as I told, here there is a roller. You can see this one. This is the roller.
Yes.
Okay.
It will be in the inside of the tank.
No, not inside. It is on the roof. This is the roller
On the
roof.
yeah, okay.
Whenever it goes up, this roller will comes to here in this end. The pontoon where it comes here. So accordingly, whenever it comes down, it comes backside here. So like that. So it is rolling on the deck. So accordingly, the length, whatever the length we decided, it will comes to till end, again till left end, again whenever it up, it is left end, and whenever it's down, it is the right end. So this,
right,
it's moving on the. There are rails are there on this deck.
It's on the roof.
On the roof. On that rail, this circular one roller is moving, and accordingly, this ladder is up. It's just going forward and backward. So you can just climb. You can go down wherever the deck will be there. Like that.
Okay, understood.
And this is the drain. We're draining. So this is also the drain. Also is something like that only. Whenever you can see on this picture. So this is the drain. So whenever you go down, this drain also flexible pipe is there. So it goes down. So flexible pipe goes down, and whenever it goes up, this flexible pipe goes up like along with this deck. Okay. Let's see, maybe here ladders. Yeah, you can see here. This is the ladders. Are you able to see?
Yes, sir, I can see.
Yeah. So this is the ladders where you can come. So here this is the rail for that one. So it goes front and back. So whenever it goes down, these rails are on that one. It goes front and back on that one rail. Okay.
Ravi, could you please explain the selection criteria for vent, the design of vent nozzle over the roof?
Yeah. So vent design, normally whatever the gases, as I told you, whenever your tank is down, so this deck, it comes and sits at the bottom. So on that time, the liquid, when they are draining, on that time the gases is coming inside from that vent. So gases when coming inside on that time, so whatever the gases will, the flow of that liquid should be calculated based on API this 2000, how much gases are coming in and how much your liquid is going out. So that to be matched with that one. So whenever your gases is coming in and your liquid is going out, so that gas is matched. Again, the liquid, whenever liquid is filling in and whatever, because this is deck, it's sitting on these legs. So due to that one, there might be some gases or some vapors inside. So that pushes out whenever liquid is coming in. So that when it pushes out, then there again the gases is going out. So that calculation is given in API 2000. So accordingly, we have to calculate. So how much your liquid inflow and liquid outflow we have to consider, and accordingly we have to calculate that one, the vents for this one.
So the design is with our tank manufacturer or with the roof manufacturer, and who will be supplied for this instrument vent nozzle?
Vent nozzle is supplied by the tank. If this depends again, the contractor, if he's taken the contract for complete tank, then contractor complete tank he, along with the vents and that one he has to supply. But design again, the design will be who will govern. There normally it comes the who does the tank design. No, that person will do this vent design also. So he will inflow. He know the inflow and outflow of this gases and liquids, and this value it comes from the process. The how much to be inflow and how much to be outflow. So this value comes accordingly. He will API 2000 he'll apply and he will calculate that vent size of. So this for this size or this flow, whether your vent will be suitable or not. This is done by the mechanical person who will do the complete tank design.
Okay.
Anything? So this is so deck whenever comes down or up, it's moving this one. See, this is the rolling riders. This is vent. So this is vent when it's going out here. When this is liquid, so you are filling from here, this liquid. When it fills up, so whatever the gases is going out from there. So again, you have to calculate. And when you're taking out, the vice versa. The gas is coming in here from here. Okay.
Okay, Ravi. Thanks.
Okay. Okay. Any more questions on these tanks, or we will move to some other topics, or anybody want to ask, or anybody want to share something, they can welcome. Just review.
Yeah.
So you reviewed this floating and that pontoon puncture and that one also, no? How many pontoons to be punctured, and then
Yeah, that roof part will be by the different vendor, and the tank is by the different vendor.
Okay, okay.
That was the case, and it was the internal floating head. So there is a top roof also by some another vendor.
Means it is a okay. So cone type, this one, another on top there up. Okay.
Yes.
So that is another vendor. So this design with supply, or only the design with one vendor and supply with another vendor, like that?
Yeah, it designed and supplied by another vendor. The scope for the roof is by another vendor, and the tank shell bottom plate is by the another vendor. Okay.
So, but design is same who is manufacturing, or it should be done by some engineering consultant who
No,
given the design?
by the manufacturer. Designed by the manufacturer only.
Okay, okay. They are only designing and they are only supplying. Okay.
Yes.
And they given you for just to review that one. So, okay. So, what are the issue you found in there? You any comments you found, or any mistakes or anything?
Yeah, there was some comments about the some code what they have selected for the calculations of the roof. So they have their own design. They have not yet submitted the detailed calculations. So I was given the comment to submit the calculations. Rest of the things are okay. And just so I have found these vent calculation also. So as you said correctly, it is as per the API 2000.
So it is a
It's a
recent.
simple project.
Okay, so it is recently you had this one, right?
Not recently, but it's it's almost 2-3 years went
before. So then it might be finalized, or still it's in review stage?
No, it's already completed.
Completed, no? Okay.
Yeah.
Okay. Anybody done any like floating roof tanks here?
Tool will be used to design the floating roof. The software.
Software and that one we used Excel only, but now many are saying that e-tank and the tank this are there. They also can do.
You are taking classes from this?
No, we are not taking any classes. You want classes? We will. Our engineering company, we are doing, as I told you, ours is engineering company which is located in Pune, and we are doing the design drawings of this one. But we are not taking any classes for this one. Just we are weekly. Normally, whatever issues we faced, we will come together and we will share some topics. And who are interested, they can join us. And maybe the similar problems or similar issues who are faced, they can ask. Like API now, he asked how the vents calculation. He will ask some queries. And who knows that one, they will answer like that only. We are doing. We are not conducting.
No, sir. Actually, my colleague asked that question to me when I was turned on in the mic.
Okay, okay. So if
It's
you
my mistake,
want any classes for this one, we can arrange. Where are some our friends are there? They are taking classes for this one. We can arrange for that one.
Okay.
But it is, but not directly from us. With our friends, and we can.
And am I allowed to ask a few doubts related to the static design of other tank?
Yeah, it's open to, because we are just a general discussion only we are doing. Yeah, you can.
Okay.
Yes, Stalin has some questions.
Yeah, Stalin, you can continue.
Yeah. Shall I share my screen?
Yeah. I will stop my sharing my screen.
It is maintained as 22 and 10 mm thickness, and the trunnion also is having the diameter of 650 and 24 thickness. I have to check this one with some standard or something, available standards or engineering practices. So how should I make sure whether this design is right or wrong? I'm not sure on this.
Anybody want to answer?
Like this is a tank which is having a diameter of 6.5 meters and the height of 12 meters. So it's rested on this ring supports on the structure. So it will be like this. It is mounted on like this ring, full ring, and will be having cassettes in as a 12 numbers. So this is the.
Yeah. So Stalin, if I understand your question right, you want to know how to design your support and how to design your trunnion, right?
Yes.
So
yes.
I mean, which software you're using for this?
This one PV Elite we are using.
Yeah. So in PV Elite you can design, no? You can design that.
Actually, the PV Elite it is specifically for the pressurized vessels or something. This is just an atmospheric tank.
No
It is
problem.
having more pressure.
Still, you can do that. You can use PV Elite. No issue.
Yeah, if I use the PV later, I'm getting the thickness of the base plate or some supports as more like 36 mm, 41 mm, something like that. So how to optimize that one? I'm not sure on that.
As far as
If I open another model. So if you see this model, the height of this shell itself is 2400, and the diameter is just 2000, but it is having the base plate of 26 mm thickness.
Yeah, often the thickness is because of your anchor bolt also. What size you are given, that depends on that also.
Okay.
Yeah. So, I mean, in industry, I mean, generally people will rely on PVLite only. Yeah. But if you really want to optimize it, you can do some manual calculations. Like you can use some like there are books available. You can refer to those. Maybe bad now or something like that, and you can verify.
Okay.
Stalin, your issue is how to arrive the values for this trunnion in that one, or complete vessel or complete.
No. Actually, he is looking to optimize the thicknesses. I mean,
the thickness. This was done on basis of EAL design considerations.
So you want to optimize only this part, or you want to optimize complete vessel?
The only this part, rest of everything is fixed for now. That looks fine. Only I'm not sure on this trunnion and the supports.
So Trunion and that support, I think even if you go with PVLite, because PVLite where your sizes comes more, whenever there is pressure parts, on that time your pressure will come that parts thickness, because this takes a ASME section 1 that factor of higher factor and that one. No? That's why the thickness comes more rather than atmospheric calculation. So the thickness will be less. No? So, but this Trunion and that one, this is again, it's considered as a it's not higher the design factors and that one. So you can reduce that one, and by using the FE or any other software where your thickness will be minimum there, where the factor of safety they consider less. So by using that one, you can reduce the thickness and optimize the things.
But Ravi, looking at the size of the tank, it seems to be not that very high.
Yeah, but he want to just reduce one part also. We can do in this one. No, if he just he want to Tronian, he want to reduce, and maybe the lug support or
what's your empty weight and operating weight?
The empty weight is 3 tons.
29 tons.
Sorry, 30 tons, and operating weight will be 55 tons.
But for 30 tons, it may look okay. I mean, why you won't optimize? I don't know, but you are having
this
any
projection, everything is looks fine. Like it is 2 feet. The projection is around 2 feet. Will it usually like this? I'm not sure on this. Just want to ensure from your experience.
no, optimizing again. It depends on how much weight we have to consider and that one, and whether it can take that weight or not. That we have to see, and again the calculation comes. So if it passes, then only we can say it's okay. We can go reducing that. But if you refer some of
for
the,
me, for me, it don't look very high. Maybe it is okay. Maybe if you do analysis, maybe you can save a little bit. But
yeah, this brackets and Trunion, it's not that much weight. What your complete your equipment weight is there. No, it's just small part. It is in that one. So even if you optimize,
Actually, this bracket is covering overall the tank circumference. So there is some impact in that.
okay, you can refer some of the standards also, like your ADNOC standards or EL standards.
Any standards to specific.
Yeah, there you can find the directly size of that one for how many tons, which Trunion size can be selected. So by that one also you can see whether it can be okay or not like that. Otherwise you can do with softwares or something. Okay, any more?
Thank you.
Thank you. Bye. Good night.